Hello friends, I am back with my this video. I am Dr. Rajesh, and today this will be in continuation in which we have determined the order of an element and taken an example. So this is new example, and let us read out the problem. Problem is G be a group and having the element 0, 1, 2, 3, 4 and 5. Question is find the orders of elements of the group G under the binary operation addition modulo 6. Now firstly we shall see what is the binary operation addition modulo 6 that I have already taught in the class, that it is equal to the least non-negative integer left as remainder when a plus b is divided by 6. Okay, and under addition modulo 6, under addition modulo 6, the identity element is is 0. That we have already discussed. Now problem in this that we have to find the order of each of the element. Order of 0 will be 1 because 0 is equal to identity element, and we have discussed this in the previous video, that identity element has a order 1. Now next we shall see what is the order of 1. Now let us say 1 plus 1, this will be 1 square, and this will be equal to 2, and remainder when 2 is divided by 6, remainder is 2, so this will be 2. Now if we see 1 cube is equal to 1 plus 1 plus 1 is equal to, now we have to follow the associativity principle because it forms a group, so I am using this associativity. 1 plus 1 in this 1 plus 1 is 2, so I am writing here 1 plus 6 is 2, and 1 plus 2 is 3, and 6, this is equal to 3. Similarly 1 plus 4, I am going to write 1 plus 1 plus 1 plus 1 addition modulo 6, so I have to use the, for 3 we know the result, for 3 we know that this is equal to 3, so this will be 1 plus 6 is 3, so this will be 1 plus 3 is 4, when divided by 6 this gives 4, so 1 4 raised to the power 4 is equal to 4. Similarly 1 5 1 plus 6 plus 1 1 1. Now see, we have to, when we have to add more than 2 elements, then we have to follow the associativity principle. Firstly we add up to, then we add the result to 3, so this is the associativity principle. That is why we are doing something like that. We have to add 5 elements, and the result for 4 is given by the above equation. So in this case we can write 1 4, this is 4 from the above case. Okay, and 1 plus 4 added is 5, and this is divided by 6 under addition modulo 6, this will give 5. Similarly we raise 6, this will be 1 plus 1 plus 1 plus 1 plus 1 plus 1 under addition modulo 6. This will be for 5 we have the result. Okay, for 5 we have this is 5, and 1 is added to 5, result is 6, and under addition modulo 6 is 0. When 6 is divided by 6, we get the remainder 0. Okay, therefore we have obtained order of 1 is equal to 6, because this 0 is equal to identity. This implies that 1 raised to the power 6 is equal to 0 is equal to identity, and 6 is the least positive integer which is raised to 1 gives the identity, because when we try to raise the 5 we get 5, 4 we get 4, and when we try to raise 3 we get 3. So this 6 is the least positive integer which is raised to 1 gives the 6. Therefore order of 1 is 6. So this is the order of 1 is 6. Next we have to determine the order of 2. Now let us see under addition modulo 6. 2 1 is equal to 2, addition modulo 6 is 2. 2 2 2 2 2 when added to 2 will give 4, and under addition modulo 4 is 4. Now we have more than 2 elements. 2 plus 2 plus 2. Okay, so associative principle comes into the action. When it is added 2 times, the result is given by 4. So I am going to write it here as 4. When 2 is added to 4, result is 6, and under addition modulo 6 this will give the remainder 0. This implies that 2 raised to the power 3 is equal to 0, which is the identity. This implies that order of 2 is equal to 3. So order of 2 is 3. Next we determine the order of 3. Next element, order of 3. 3 raised to the power 1 is equal to 3. Under addition modulo 6 this will give 6. 3 2 is 3. 3 6 under addition modulo 6 will give the remainder 0. This implies that which is the identity. 3 2 is equal to 0 is identity. Therefore order of 3 is equal to 2. So order of 3 is 2. Next we see the order of 4. For this, let us see 4 raised to the power 1 is 4. Addition modulo 6 will give 4. 4 2 4 4 8. Addition modulo 6 will give 2. 4 3 4 4 4. Now we have to use the associativity 4 6, and from the above we'll get 2. We'll get 2. So this will be again 4 added to 2 is 6. So this will be 0. This implies that 4 3 is equal to 0 is equal to identity. This implies that order of 4 is equal to 3. Now next we determine the order of 5. 5 1 is 5. Addition modulo 6 is 5. 5 2 5 5 is 10. Addition modulo 6 is 4. 5 3 5 5 5. Addition modulo 6. For 2 we know the result is 4, and when 9 is divided by 6 we get the result as 3. 5 4 5 5 5 5. Addition modulo 6. When for 3 we have the result. For 3 we have the result, it will be 3. So we are doing this because associativity principle we have to take into the consideration. We cannot ignore the associative principle when we are adding more than two elements. We have to use the associativity principle, whether it is left associative or right associative. So this will be 3, and when 8 divided by 6 we get 2. Now 5 5 5 5 5 added 5 times under addition modulo 6. So when it is 4 times, you know the result is 2. Okay, it is 7 added, and when it is divided by 6, remainder is 1. Now 5 6 5 5 5 5 5 and 5. This is added 6 times. Now see, this 5 when added 5 times gives the result 1 from the above case. So this is further, when 5 is added to 1 is 6, and addition modulo 6 is 0. This implies that 5 raised to the power 6 is 0 is identity, therefore order of 5 is 6. Now therefore we have determined all the orders. Order of 0 is 1, order of 1 is 6, and order of 2 was 3, order of 3 is 2, order of 4 we determined as 3, and order of 5 is 6, and group given was 0 1 2 3 4 5. Now if we are asked that what is the order of the group, then in that case you will write, since it has 6 elements, we can count the element 1 2 3 4 5 and 6. So it is a finite group. Finite group is a group that is having a finite number of elements. This is having finite number of elements, and we can count, and the number of elements in a finite group is equal to the order of the group. So order of the group is 6. So here we see that the order of none of the element is greater than 6. At most it can be equal by the theorem that we discussed in the last lecture. At most the order of any of the element could be equal to the order of the group, and it cannot exceed. It can be less than, but it cannot exceed. Therefore that theorem is also verified here, because the maximum order is 6 of 1 and 5. So that is the theorem. We have determined the order of the different elements and order of the group, which was a finite group. So in this lecture we have learn how to find the order of the group which forms a group under addition modulo 6. Similarly, we will try the relevant problems, and we will try to find out the orders, and we also find the order of the group. When it is a finite group, you will count the number of element it is having, that will be equal to the order of the group. In exam sometime they may also ask that what is the order of the group. So in that case this will be the order of the group. So this is what I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. You may ask your queries in the comment section, and I will always appreciate and welcome your queries, and will definitely reply your queries. Thanks for watching, and you just keep studying, and if you have liked the video, just subscribe the channel. Thank you very much. This is Dr. Rajesh saying you goodbye. Keep studying. Thank you very much.